about the vector calculus. This is Dr. Sharma, Professor, ECE Department, BBC Engineering College, Vadalre. What is vector calculus? There are two types of integrals that what we have to represent or we have to know. One is about the line integral, second one is about the surface integral, and third one is about the volume integral. What is a line integral? The line integral is a vector is the integral of the dot product of the vector and the differential length vector tangential to a specified path. For a vector f bar and a path I, the line integral is given as integral t with f dot dl bar is equal to integral a to b mod f of cos theta dl. This is the line integral. Surface integral. For a vector f bar, a continuous in region containing a smooth surface. Yes, the surface integral of the flux of f bar through the S is defined as phi is equal to surface integral of f bar dot ds bar. Here ds bar is nothing but the surface area region. So with respect to that, integral S of f bar dot an into ds is equal to integral S surface integral mod f bar cos theta ds. And next one is about the volume integral. The volume integral is a scalar quantity f over a volume v as written as u is equal to volume integral of f dot dv. The concept of volume integral is to calculate the charge or mass of an object with the distributed in the value. Next one is vector differentiation. In that first one is differential vector operator del. The differential vector operator del is to be otherwise called as the nabla, which is to be represented in the Cartesian coordinate system of x, y, z. Del is equal to dou by dou x of ax plus dou by dou y of ay plus dou by dou z of az. This del operator is otherwise called as the nabla. Second one is gradient of a scalar. A gradient of a scalar function is both the magnitude and the direction of the maximum space rate of the change of the function. And the mathematical expression for this gradient vector is to be represented with a scalar function of f. A mathematical expression for the gradient can be obtained by evaluating the field df in between the two fields p1 comma p2. Here, if we see here, there we are taking a Cartesian coordinate systems of x, y, z, and the point which is to be located here. From that, a P1 is one region and P2 is the other region. The distance between P1 and P2 with respect to that F2 is equal to F1 plus df. So from here, F1 and F2 are to the counters of the counters on which f is constant. Therefore, df is equal to dou by dou x of f. Here we are representing the force. Dou by dou x of f dx plus dou by dou y of f dy dou f by dou z into jz. So with respect to that, which is to be represented like this, that is to be called as g bar dot d bar. G bar is nothing but the force which is to be acting between the points p1 and p2. So dl bar is equal to dx into ax and dy is equal to dl bar is equal to dx ax plus dy ay plus dz az. It is nothing but the differential length or the differential displacement from the point p1 to p2. So df is equal to g bar dot dl bar, that is equal to gdl cos theta. Df by dl is equal to g cos theta. Therefore df is equal to gdl cos theta, where theta is the angle between the g bar and dl bar and g bar. So it is the angle between the dl bar and the g bar. And for the maximum df by dl is for the maximum of df by dl, theta is equal to the 0. So from that, the gradient which is to be represented as gradient f is equal to del f is equal to dou f by dou x into ax plus dou f by dou y into ay plus dou f by dou z into az. So this is the most important equation where we are discussing about the EMWTL and the physical interpretation of this gradient of a vector. For example, if we consider a room in which the temperature is given by a scalar field T at any point of x, y, z. So with respect to that, the points may be changed, but the temperature may not be changed with respect to the time. So from all this, we may represent the gradient of a scalar in the three different Cartesian coordinate systems with respect to that del f is equal to dou f by dou x into ax plus dou f by dou y into ay plus dou f by dou z into az in the Cartesian coordinate system. In the cylindrical coordinate system, as we know that r, phi, z are the coordinates of that one, dou f by dou r into ar plus 1 by r into dou f by dou phi into a phi plus dou f by dou z into az. In the spherical coordinate system, as we know that rho phi, rho theta phi are the coordinates with respect to the dou f by dou rho into a rho plus 1 by rho into dou f by dou theta, a theta plus 1 by rho sin theta into dou f by dou phi into a phi in the spherical coordinate system. So what are the properties of gradient? The magnitude of the gradient of a scalar function is the maximum rate of change of the function per unit distance, and the direction of the gradient of a scalar function is the direction in which the function changes most rapidly. So the projection of the gradient of a scalar function says that the direction of is in the direction of the unit vector. Next one is the divergence. Divergence is nothing but diversification. So with respect to the divergence of a vector at any point is defined as the limit of its surface integral per unit volume. Divergence of f is equal to del dot f is equal to limit v tends to 0. From there we may represent the divergence of a vector, okay, that is equal to limit v tends to 0 circular surface integral of f dot an into ds by v. This is nothing but the divergence of a vector. So what are the properties of the divergence? Divergence of a scalar field has no meaning, and divergence may be either positive divergence or a negative divergence with respect to that examples where we are using there. Okay, and next one is about the curl of a vector. It is one of the important one. The curl of a vector field, it is represented as curl f or del cross f. It is to be the vector having the magnitude equal to the maximum circulation at which the point is to be perpendicularly to the plane of circulation for each point. So the curl of vector, which is to be represented as curl f bar is equal to limit delta s tends to 0 circular surface integral of line integral f dot dl by delta s into an, where the direction of the contour is obtained from the right hand corkscrew rule. And properties of curl. Curl of a scalar field has the no meaning of that one, and the value of the curl of a vector field is 0. Then the vector field is said to be the irrotational or a conservative field. And Laplacian operator del square. Del square operator both on scalar as well as in the vector field. Laplacian del square of a scalar is to be represented as del square of L f is equal to delta del f. Okay, so from that we may represent the final equation is dou square f by dou x square plus dou square f by dou y square plus dou square f by dou z square. The Laplacian of a scalar field is also a scalar field. Stokes theorem. Stokes theorem is combines the ideas of the Green's theorem and coordinate vector field. So the statement representing the Stokes theorem is nothing but the line integral of a vector around a closed path is equal to the surface integral of the normal component of its curl vector. It is nothing but the Stokes theorem, which is to be obtained from the right hand rule. So circular line integral of f bar dot dl bar is equal to double integral of surface into del cross f dot an into ds. So this Stokes theorem is very useful for us for in the further calculations while you are discussing in the electromagnetic